Hello friends, in this lecture we will learn about ARP and reverse ARP. So what is ARP? ARP is Address Resolution Protocol and reverse ARP is again Reverse Address Resolution Protocol. So we will understand about it. So what happens is when you are on a local area network, so we operate on two addresses for a host. So one is your logical address, okay, for example your IP address, and then we also have a physical address which is the MAC address of 6 bytes. So how to make a relationship between these two addresses, and in this ARP and reverse ARP helps. So if I know the IP address of one machine and I want to know the physical address for it, I will use ARP, okay? And when I know the physical address and I want to find its IP address, I will use reverse ARP, okay? And why is that needed? So let's try to see. And these both ARP and reverse ARP are there in the network layer protocol, okay? So let's try to see. So first we will learn about ARP. So ARP associates an IP address with its physical address, okay? So for example, there will be a table which will tell 132.28.36.5 has a physical address, okay? So it's A2 B5 38 21 00 FF, okay? So these are 6 bytes of MAC address. So this is your IP address, and then it gives your physical address. So this mapping is being done by your ARP protocol. And why is it helpful? Because when we are sending packets on a LAN, then we are sending frames, and that use the MAC address for communication. So the topics that we will discuss now for ARP is the packet format, because it's a packet where we have what are the things that we need, what are the fields that will be used for communication, okay? So it's something like I'm talking to you and I'm asking your name. So there are some questions, some field will be there, and what operation it does, what is the encapsulation, and so on. So let's try to see with one very good example. So there is a system A and this is a LAN, okay? So this is a LAN. There is a system A, and A wants to know that what is the MAC address of system B, which has IP address 141.23.56.23. okay? So it wants to know its MAC address so that it can send now frames directly to it using that MAC address, okay? So, and because their communication on a LAN takes place using the frames where you have to know the MAC address, and I don't know that, okay? So for example, I come to a class, okay, and then I need to broadcast to everyone that who is some person, John or something like that. Then I will tell to everyone in the class who is John, and only John will raise his hand that okay, I am John, okay, and all other people will be sitting, okay? He will stand up and tell that he is John. So when I ask that okay, what is the MAC address for this IP address, so here I don't know if this machine A, B, C or this system B, okay? So this is not B, this is D, this A, D, C or B, which has IP address 141.23.56.23. So when this question or request goes to each one of them, then B will find that okay, this address belongs to me, this IP address, and now he will reply back, and only he will reply back. Others don't need to reply because they are not system B with IP address this. So it's something, again the mapping is, if he is there, he will only stand up and say okay, I am John. Others will not say okay by standing up that okay, I am not John. This will create too much of noise. Similarly, if they are sending reply that I'm not this IP address, then that is useless, okay, and that will add to congestion and collision in the Ethernet. So what happens? B replies that okay, I am this particular IP address, and he replies with its 6 bytes of MAC address, which is A4:6C F4 5983AB. Okay, so this is how you write the MAC address and in the human readable format. So okay, this is the first byte, we write in hexadecimal, then we put a colon, we write 60, which is next byte, F4, then 59, then 83, and AB. Okay, so ARP is reply is unicast and ARP request is broadcast. I asked to each student in the class, only John replies that yes, he is John and his roll number is that particular one. Now let's come to the ARP packet. Okay, so what are there in my request? So let's say I'm sending by mail to each student that who is John. So what are the things I will write? So similarly, the per system is asking about the hardware address of particular IP address. So what he needs to write, he will send also his sender hardware address, his own IP address, which is 4 bytes, this is 6 bytes. Then he doesn't know what is the target hardware address, so this is not filled, this is filled, this is filled. He doesn't know that, he will not fill this up. And he knows the IP address, so he fills this, and by reading this one particular thing, the system B will know that okay, I have to reply with my hardware address. But then again a few more question remains, that how will he know that okay, this packet is an ARP request? Okay, so that will be from this field. Okay, so it's kind of a letter that you receive, in that a lot of header messages are there. So it tells that okay, protocol type is ARP. Okay, is this a request for ARP or ARP reply? Because it can be an ARP request or reply. So I will say no, it's a request. And what is the length of the protocol, hardware length, hardware type, and so on. So these informations are given. So I will first see protocol type is ARP, it's a request. So I will check that okay, is this asking for my IP address? Yes, I'm John, or system B. So I will reply with my hardware address, and that reply will be ARP reply. Whom to send? So I will send to the sender's hardware address, MAC address. Okay, so this is there. Next, so this is how the encapsulation happens. So this is the data, you have the source address, destination address, and so on. Now this one is interesting. Okay, so let's try to see this one. So what are the cases for using ARP? So case 1, okay, what is the target IP address? So I am on a particular LAN, okay, and the other host, the receiver also, whom I want to send some frames, he is also on the same LAN. I know his IP address, but I don't know his frame and his MAC address. So if I don't know his MAC address, I cannot forward packet to him. So what do I do? In the LAN, whoever are there, I will send a broadcast ARP request saying that okay, this is the IP address of host and I want to find his MAC address. So this broadcast request goes to all the machines, but the particular host only replies with his IP address. This was the thing we saw also. Next one is, I'm sending, a host want to send a packet to some other network. Okay, so if you are sending to other network, it must pass through this gateway router, and to send it to a gateway router also I need to know the MAC address of that particular router, okay, to the port to which I am connected. So again I will send that okay, what is the MAC address of this particular router. So again I will send a broadcast ARP request, and this router will send a and unicast ARP reply. So broadcast is to everyone, unicast is to just a single user. Then the next one, okay, so now there is a LAN in between. So a router receives a packet to be sent to a host on another network. So there was a LAN here, there is a LAN here, okay. So this LAN person, LAN 1, and this is, let's say, LAN 5. So a host in LAN 1 wants to send to a host B in LAN 5, okay, so host A. So first he needs to send here. So this router is connected through a LAN to this router. So this router needs to know the MAC address of the router for which is connected to LAN B. So it will send a broadcast request to the router's IP address, okay, to which IP address, saying okay, which particular router has this IP address, please send me his MAC address so that I can forward you the packets. This is the third case. Last case is this, let's say this router receives the packet forwarded by A in LAN 1. Now what if he doesn't know who is B, what is the MAC address of B? Then he also again sends an ARP request. He broadcasts it to all the hosts. Then host with that particular IP address replies, okay, I am this person, and he sends his MAC address. So that router can send the packets forwarded by A in LAN 1. So this is about the 4 cases of ARP, which is interesting. Okay. Next, so ARP request is broadcast and ARP reply is unicast. So host, so this just tells you, okay, so move forward. Now we will come to how is it stored, okay, cache. So we will solve a few problems to understand this ARP. So there is a cache table, okay, there is a table where this IP address and the particular MAC address are stored. This ARP package, it's a software package, so it also contains queues, different queues for different MAC addresses to which packets are to be sent, and a cache control, how we update it, how we modify it, and so on. So this is there, okay, let's try to see. So there is the IP packet comes to this IP layer, okay, then there is an output module. So now IP packet goes to these different queues, okay, and these queues are for different MAC addresses, okay. So if I'm sending to MAC address 1, it will be there in Q1, okay, something like that. If I'm sending it to MAC address 5, it will be in Q5, and then all the IP packets are forwarded. This is the cache table. I can receive an ARP request, I can receive, so this we can also get a request, ARP request reply. So let's try to see it with questions. Okay, so let's try to see. So this is a cache table for our example. So here you see there is a state, there is a queue number, number of attempts, timeout, the IP address and its hardware address. Okay, so these things are there in the table. So state, let's try to see. State R means that, okay, I already know that, okay, for this IP address you have this particular MAC address and it's resolved, and this queue number tells you that, okay, if you are forwarding packet to this particular IP address, you need to send it into queue number 5. This is saying that, okay, it's pending. It means I have sent an ARP request to find what is the MAC address for this particular address. I have made 2 attempts. The packets that are coming to be forwarded to this particular IP address are there in queue number 2, but I still don't know its MAC address, so I cannot forward those packets. So P is pending again, so it also not knowing IP address, MAC address for 201.11.56.7. F, okay, so it says that, okay, so it's now time, so nothing is there. So let's try to see. So we have a few interesting questions here. So first one is, now what happens, our output module receives an IP datagram. Okay, so it gets an IP packet with destination address this 114.5.7.89. It checks the cache table. Now it will check the cache table, and if it will see that do I have the MAC address for this one. If it has, it can forward it to that particular queue. But if it doesn't exist, okay, so if it exists, the state will be R. Okay, it extracts the hardware address. It can then extract the hardware address and send the packet to the data link layer for transmission. So let's try to see. So what was the IP address? It was 114.5.7.89. So 114.5.7.89 is there, so it could find its state is R resolved. So I will send the packet with, because I know the MAC address. Okay, so let's try to see. So this is fine. Next it says 20 seconds later. Now what happens, our output module again receives an IP datagram from the IP layer with destination address this. So now again, so now we have to check, does this IP address, is it present in the cache table? If it is, then it is fine, but if it is not, then what will I do? And let's try to check if it is there. 116.1.7.22. So 116.107, there is nothing like 116 here, so that is not there. So what they will do now, he will, because I don't know the MAC address, I will send an ARP request and I will put an entry in the table for this IP address, but I don't know its MAC address now, so I will put a pending in the state. Okay, and I will make a queue for it. So now what happens, let's try to see. This is 116.1.7. so where is it? I have a entry now in my cache table. I said that this is my attempt 1 to find its MAC address, and the queue number is 23. It is in pending state because I don't know the MAC address now. Then what happens 15 seconds later? So again 20 seconds later that request came. Now again 15 seconds later, our input module receives our packet with target address 188.11.8.71. The module checks the table, and okay, so let's try to see 188.11.8 188.11.8.71. okay, this is the IP address, and let's see. So ARP input module receives a ARP packet with this, so it is receiving an ARP reply. So now it says that okay, now I have got a reply for this, so I know its MAC address, so it is resolved now. And then there is a timeout value that okay, it will be there for 900 seconds or something like that. And then I know from the ARP reply that okay, its MAC address is this, so it is updated here. So what was the address? 188.11. so 188.11, so this is there, and its MAC address I found. I put a timeout like this. Okay, and it is in Q18, so whatever packets are coming to it, it will be forwarded to Q18. Next 25 seconds later, the cache control module updates every entry. Okay, so we started at time 0, then there was 25 seconds, after 15 seconds, then 20 seconds was there, 15 seconds, 35 seconds plus 25. Overall it became 60 seconds. Okay, so cache control updates every entry. So what will happen now? The timeout will decrease for each value. So because it has passed 60 seconds since the first update, so all the time out will be decreased by 60. Okay, only for the last one which was just updated 25 seconds ago. Okay, because that entry was added, so it was decreased by just 25 seconds. So you can see that here all of the entries are decreasing. So it's 840, initially it was 900, this was 450, it became 390, and so on. This was 900, after 25 seconds it became 875. Now we will just look at reverse ARP. It is reverse of it. So now what happens is that now I know my physical address, but I want to know my IP address. So it goes to the reverse ARP server. I tell that my IP address, this is my physical address. It will provide you the IP address. So this is therefore reverse ARP operation. So I hope you understand this concept of ARP and reverse ARP. It's very important. So thanks a lot.